about midpoints and bisectors, which are both very similar concepts because they both have to do with cutting something in half. So let's start with a midpoint. And a midpoint is a point that is exactly halfway in between two other points. And you can kind of tell by the name, midpoint is the middle point, the very exact middle point. So if you're talking about a line segment and you find its midpoint, it's going to cut it into two congruent segments. Remember, if you cut something exactly in half, you're cutting it into two equal pieces. And for line segments, for shapes, we don't say equal, we say congruent. So you're cutting it into two exactly the same congruent line segments. So here's a picture. We had line segment AB. We used M for midpoint, the red one. And because it cut it exactly in half, we marked them congruent. And actually in this picture, this is one I found online and used, they used two markers here and here. They really only needed one, because remember, you can just use one to show congruent and then two to show more congruent. But that's okay. 2 means congruent. You know, as long as it has the same number of those little markers, it means they're congruent. So in this picture, line segment AM is congruent to line segment MB. And that's what a midpoint is. Now let's say we're talking about numbers instead of a line segment. The midpoint of two numbers is like finding the mean. And remember, mean was one of the things we did right at the end of first semester, right before the break. To find the mean is when you add a bunch of numbers up and you divide by however many there were. Well, when there's only two of them, you just add them up and divide by 2. And that's how you find the midpoint. So for example, let's say we wanted to find the midpoint of 7 and -2. Just two numbers, 7 and -2. So I'm going to add them up and divide by 2. It would look like this. I would do 7 plus -2, add the numbers, and then divide, or I did a fraction. I put it all over 2. So 7 plus -2, that's like 7 minus 2, you get 5. So 5 over 2, or 5 divided by 2, actually you could just leave that. 5 over 2 is a perfectly good answer. But if you divided it, if you wanted a decimal, it would be 2.5, or 2.5. So the midpoint, or the very middle point, this is like, think about a number line. If I had a number line, I'd put 7 on the number line and -2 on the number line, and I wanted to find that exact middle point, it would be 2.5. I wasn't supposed to be there yet, that's okay. So let's say we want to find the midpoint of 2 points in a coordinate plane, just like we did with distance formula yesterday. So we have 2 points, x1, y1, and x2, y2. What we're going to do is we're going to use the concept we just talked about, but do the x's and y's separately. And that's what we call the midpoint formula, which was already on the screen. No, accidentally, it wasn't supposed to pop up yet, but there it is. So this first part over here is basically finding the midpoint of the x's. Add them up and divide by 2. And then this part over here is basically finding the midpoint of the y's. Add them up and divide by 2. So that simple concept that we just did with the 7 and the -2, if you do it twice, you get the midpoint in the coordinate plane. So let's do one of those. Let's find the midpoint of -5, 2, and -9, 5. So let's label our points like we did with distance formula yesterday. Let's make the first one x1, y1, and make the second one x2, y2. And for the midpoint, we'll call it M for midpoint. We're going to do first the x's, we'll add them up, x1 plus x2, and divide them by 2. And we'll do the same thing for the y's, y1 plus y2, and divide them by 2. So for this question, if I add up the x's, it would be -5 plus -9 divided by 2. And it would be, for the y's, it would be 2 plus 5 divided by 2. So -5 plus -9 is -14. 2 plus 5 is 7. So for my final answer here, the first one we can do. Negative 14 divided by 2 is negative 7. You just get a whole number. The second one you don't. 7 divided by 2 would be a decimal. I'm not going to put it as a decimal though. I'm going to leave it as a fraction. I'm going to leave it as 7 over 2. Although if you wrote it 3.5, that wouldn't be the wrong answer. It's just unnecessary extra work. If you get one of these that comes out as a fraction, we'll probably just leave it. So the midpoint of negative 5, 2 and negative 9, 5 is negative 7, 7 over 2. Now, even though this wasn't part of the question, let me sketch this real quick. Let's plot these 3 points and we'll see if it looks like the midpoint. So if I did a quick coordinate plane here, oops, pen's acting up a little, okay. So I'm going to kind of approximate here. I'm not even going to count squares on the numbered lines. But if I went negative 5, that would be 5 to the left and up 2. Let's say that's the point negative 5, 2. And then for the next one, I went 9 to the left, negative 9, and up 5. That would be up here. The midpoint, M, if I guessed a point exactly halfway in between them right there, that would be like negative 7 here. Remember, this was negative 5, and this was negative 9. So I basically found the midpoint of the x's to be negative 7. And then I did the same thing for the y's. I said right here, the height of this point was 2. The height of this point was 5. So the halfway point for those would have been 7 over 2, or 3.5. So all you're doing is the x's and y's separately. You can see like right there the negative 7 is exactly halfway in between the negative 5 and the negative 9. And right here the 7 over 2 is exactly halfway between the 5 and the 2. So that's how midpoint works in the coordinate plane. It's pretty simple. It's not a distance formula yesterday was a little bit harder because it had that big square root in it. This is a much easier formula to use. Okay, the second part of the notes, or the second part of the title today, was bisector. Now I said it's very similar. To bisect something means to cut exactly in half. And that's why I said a bisector is actually very similar to a midpoint. Yeah, this is what I just said. Bisect something means to cut exactly in half. So basically, a bisector is like a midpoint, but it doesn't have to be a point. It can be anything. A midpoint is a point. I mean, it says it right in the name. But a bisector could be something else, like this right here. So here we have this picture. Take me out of there. We had line segment AB. Now it does have a midpoint. It has midpoint M. This is the midpoint right here. But see how that line CD goes through the midpoint? Line CD is what we call a bisector because it bisects or cuts in half line segment AB. So the point M is the midpoint. The whole line itself, line CD, is the bisector. But you can answer the same types of questions about them. You know, either way, what it's doing is it's cutting AB into two congruent pieces. See, this piece is marked congruent to this piece, just like the midpoint. So when you're answering questions in the homework tonight about midpoints and bisectors, it's going to be pretty much the exact same question. It's just going to be about the relationship of those line segments being equal or congruent, and then using them to solve questions. You might solve for x or figure out how long they are, things like that. But that's midpoints and bisectors, very, very similar concepts. It's all about cutting something exactly in half, which then in turn creates two congruent pieces.